Smarter City Horizons 2020 European project, which is looking for a systemic approach for transforming European cities into sustainable, smart, and resource-efficient urban environments in Europe. The renovation activities that are being carried out on this project consist of the insulation of the envelope of the building, which includes the facades and the roof, as well as the windows in some cases, and the connection of the dwellings to a new district heating based on biomass energy. During this Bim-Speed project, new tools and solutions have been tested in this case study, and you will see some of them in the next half an hour, in the hour and a half. Just to give a little bit of context of this case study, the two buildings are in the city of Vitoria-Gasteiz, which is the capital city of the Basque Country in the north part of the country. It's a medium-sized city, and the first aim of the project, of the Smarter City project, was to make a retrofitting works in one of the districts of this city, that it's called Coronation district, which is a quite degraded area, which is very needed of this kind of projects. This is the current state of Smart and City European project. As you see, there are 26 buildings that will be connected to a district network that it's now currently being deployed in the district. And from those 26 buildings, residential buildings, 2 of them are what we have chosen to be part of Bim-Speed project. These buildings are Aldave 26 and Manuel Díaz de Arcaya 5. These are the 2 buildings. These are multi-story buildings with 4 and 5 floors, and they are very near in this area, as you can see. And we are going to show you the previous state of this building, Manuel Díaz de Arcaya 5. This is the previous state. Both buildings were built in 1958, so they have a very poor thermal insulation and a very poor energy performance, with some problems of condensation or humidity damp in many of the rooms. The external walls are typical from this period of time, from the 50s in Spain, with a double layer of bricks with an air camera between them, but it's not always like that. Sometimes there is not even that air camera. And this is the current state of this building. We have made this retrofitting work or process using ETHICS, external thermal insulation, in the facades and in the roof, and as well you can see that there are new windows. In some of the cases they are double windows. We keep the old or the former window, and we put a new window that is just in the facade to make to have a better performance, thermal energy performance of the building. This is the other building, Aldave 26. It's quite similar to the other one in terms of characteristics, with no insulation as well, and with some structural problems that have to be solved. And this is the current state after the retrofitting works, as well with ETHICS. To implement the BIM tools, we have going through a data gathering process. Part of the process has been digital, with like this laser scanning process that you are seeing in the screen in these pictures, and with this cloud of points, we have developed. Well, Bim-Speed partners have developed these models and these drawings. We have implemented as well with other Bim-Speed partner these thermal scans that will be as well used as input in the final models. we make the thermal scans before the retrofitting works, and we will do another run of these thermal scans now that the buildings have been completed. As well, we have some data from the comfort of these buildings that we gather with some sensors. This is a sensor of humidity and temperature, as well as sensor for the electric energy consumption. And in some cases where we have detected before the retrofitting works that there could be some problems of humidity or condensation, we have installed as well a CO2 sensor. And then, in the other hand, we have the analogic process of gathering data. This means that we have gone dwelling by dwelling, talking with the tenants and with the inhabitants of the dwellings to know what were the real conditions of the dwelling. We have detected some problems as I said before, and we have as well gathered the bills, the energy gas consumption bills, to see which is the energy consumption of the buildings, to have all this data. And finally, well, some Bim-Speed partners take all this data and created the BIM models for these two buildings. We have the project model, we have the before retrofitting state model, and in the next months we will have the final model with the current state, or the as-built model. And well, this is more or less what I wanted to show you about the case study in Spain, where many of the tools have been tested. And well, if you have any question, I think that we have a question and answer session after Josephine Cook presentation. But if you have any question of this presentation, I kindly ask you of putting in the chat box. And okay, without further delay, I turn over the floor to Josephine Cook for her presentation of the Bim Maturity Tool from PB40. Josephine.
Yes, thanks. I'm going to share my screen. So, all right, welcome from my side. My name is Josephine Cook. I'm from Planbauen 4.0 GmbH. And I'm going to introduce you into the Bim Maturity Tool. Here, a short description. So the main aim of the tool is to give guidance to stakeholders regarding BIM implementation in renovation projects on the basis of their respective level of BIM maturity. And this is achieved through an online tool that guides the stakeholders to BIM use cases that are tailored to their respective level of BIM maturity. So the tool is intended to be used by any stakeholders involved in renovation projects who are interested in approaching the renovation with BIM-based methodologies. And we kind of have 3 steps to go through. So the first step, you enter general information on the stakeholder. In the second step, you give information on the company. And in the third step, you give information on the project. And then based on this, on the given information, you will receive results, which are the BIM maturity index and also the identification of use cases. So let's skip into the tool. So I'm here on the training materials webpage, and here's the link to the BIM maturity tool. So either you sign up if you don't have an account, or you just log in. And here you can see the 3 main steps. So in step 1, you enter the company information. I think this is pretty straightforward. Just give some general information like project phases, type of stakeholder, all this. So, and then you can proceed with step 2. This is the main questionnaire where you can take a scan. And this questionnaire is divided into 4 main topics. Like the first topic is policies. And we also have some subchapters. Here, for example, awareness and motivation. So then the second topic is people. The third topic are processes. And the last topic, technology. So once you have done all these questions, you can save and click on finish. But I guess this would take too long now to do all the questions. So let's have a look at the scan I took earlier, and here you can receive the results. So first, you will receive the results per topic. Like for example, the first topic, policies, 76%, and also per subchapter, you can receive the results. And for a visualization, we have a radar chart where you can see, okay, so in the first topic, I have received 76%, and this is this point, for example. So let's go back to the steps. So now we have finished step 2, and then you can proceed with step 3 and create a new project. This again, pretty simple, like the company information, just some general information on the project. For example, renovation scope, project phases. So let's have a look at the test project, which I did earlier. Here you can, before you can have a look at the use cases, which I proposed to you, you will have to enter 2 additional questions. The first one is, what are the intended goals of the renovation? For example, here, reducing energy consumption. And then what are the intended renovation processes? For example, energy performance prediction. And then you will receive a use case, in this case, assessing building energy performance with simulated data. We have some information on the use case on the left-hand side, the goal, the description, some other information, and again the visualization of the maturity. So this is your own maturity, the pink one, and the blue one is what you need for the maturity of the use case. And you can always change the use cases by editing these questions, and then you can have a quick overview of all the other use cases. So, and you can always create a new project, edit your projects or delete them. Yeah, so this was all to the web page. And so in summary, to wrap up, we did the 3 main steps, and then we received our results, the level of BIM maturity, and appropriate BIM use cases. And so, yeah, and the achieved goals were to determine the feasibility of using BIM for renovation projects, and to define the scope of BIM implementation, and hopefully to facilitate the implementation of BIM in renovation projects. So thank you for your attention, and I'm happy to receive any comments or questions right now.
Okay, thank you very much for your presentation, Josephine. Yeah, we don't have any questions on the chat box. I guess people are still a little bit shy.
I have a question.
Ah, great, and here.
Yeah,
hi, hello, how are you?
Hi, I'm okay, thanks. I have 2 questions. The very first one is to the first presenter. How does he scan the roof? How was the top of the roof scanned? That's my first question. Then my next question goes to Josephine. When do you actually use this tool in a project life cycle? Is it at the early stage or somewhere? Where, in which of the phases?
It's actually before you start even with the project. So it's just, yeah, it's at the right beginning when you just want to, when you're in the phase of gathering information.
Okay, thank you.
Okay, and regarding the first question, let me share the picture, because I think that it well, as you can see, yeah, indeed, it was scanned the roof, and as far as I know, they did it from the buildings that were just side by side with this one. I don't know if they used any other tool for this. I think that they did it like this, but I will check it with the people that did it, and if you don't mind, I will answer you later by email.
Thank you. That's fine.
Okay.
Hi, I also have a question for David. So for the laser scanner or the laser scanning, how many people were required on site?
Well, I was not on that process, but I guess that they were not many people there. I think that they came like two persons from the company that made the laser scanning. And I think that it was all. There was another one of my colleagues, Oscar Bell, who was in the project before, in the first part of Bim-Speed. He was with them, but I would say that two or three people, not more.
Okay, thank you.
You're welcome.
Okay, is there any other questions? Okay, if not, then we go to Yannick. Yannick, please, your presentation.
Yes. Hello, everybody. So let me share my screen. Okay, just give me a sign when you see the title screen.
Yes, I can see it.
Okay, perfect. So welcome everybody. My name is Jan-Erik Braun, working for Hochtief Vicon on the Bim-Speed project. And we are the leader from Work Package 1, and Work Package 1 is referring to collecting information which is required for performing specific use cases. And as Josephine mentioned beforehand, first of all, we have to identify which maturity is used for which use case, and therefore we, on the other hand, have to know which use cases are suitable to be performed on site and which fit your goals best. So we've created this Bim-Speed methodology toolkit to identify which data has to be collected for to achieve specific goals, and this is based on renovation phase, rebar stage, business processes, and therefore we get the relevant use cases and might identify which data has to be collected to fulfill those use cases. So regarding all those terminologies, we will have later on a slide where I go deeper into detail for that. But maybe one step back, a short description of the Bim-Speed methodology toolkit. Who can use the tool? It's supposed to be used by all those people who have to identify which data has to be collected on a site to fulfill their renovation needs. So the goal aims at identification of the use cases, and derived from those use cases, we would like to see which information has to be collected to fulfill those use cases and support the renovation project. So first of all, I would like to show you, and I will give a brief introduction from one step back, how we came to the solution or to the finding that we need something like the Bim-Speed methodology toolkit. So I will explain in brief what the purpose is, which challenges we identified from perspective of the industry, and what our approaches were. And then I talk in brief a little bit about the development of the Bim-Speed methodology toolkit, and finally I will show you the application. Yeah, it's not that complicated, so everybody is free to use it. But one word as a not a warning, but a hint. Right at the moment, the Bim-Speed Methodology Toolkit is a work in progress because we are linking the information from the Bim-Speed Methodology Toolkit right at the moment with the BIM Passport, and this is also required to fulfill the needs of the Bim-Speed Maturity Matrix. So we're bringing everything together, but we will see it later on. So first of all, the purpose of the Bim-Speed Methodology Toolkit. When we started with Bim-Speed project, we identified several challenges which should be addressed by Bim-Speed project itself. So regarding the data collection, to identify which data has to be collected, you must be aware which use cases should be supported. So, and by knowing the use cases, you will get more information about the required information and how detailed your information has to be. Then we encountered that the post-processing of information collected on site is very time exhausting and needs much effort. So just to bring the information into the right formats, it's very time extensive. To provide the information is the next one, which is shown, or not really shown here, but one of the main challenges is the collaboration. So if you think about laser scans, how to provide it in a proper format and how to share it with other people, that they can use it at once without any loss of information. And finally, what's one of the main ideas of Bim-Speed is that we would like to shift all the information we found in a theoretical research project to the praxis, so bring it on site. And what were our approaches regarding the data collection? We created this Bim-Speed Methodology Toolkit to enable the extraction of requirements from the use cases and identify which information has to be collected, because in the beginning, when we started with the project, we have had this work package 1 where we would like to collect the right information right in time, but we were not aware about the use cases. So we saw that it's most urgently need that we identify the use cases and derive the requirements from them. Regarding the post-processing, we would like to define methods and tools how to provide the required information right in time in the right format. Regarding the collaboration, we are about to creation or updating and enhancing the Bim-Speed platform where everything comes together. And finally, the transfer to the praxis is done by demonstration projects. We have about 13 demonstration sites, and doing such a train-the-trainer session is most important to bring everything and our findings onto the sites and into real life. So how was the development and how did we create? What were the thoughts about it? As I mentioned before, we have several main objectives at Bim-Speed we are addressing, and starting from that, we would like to identify the relevant BIM use cases and finally derive the required data to be collected from those use cases. But first of all, we have also to talk about the terminology of a use case. So we found that everybody is talking about use cases, but with slight different understandings about what is a use case is. So we started from scratch and jumped into the idea, what are the main objectives from Bim-Speed? So to summarize it, we would like to increase the energy performance, reduce costs, speed up refurbishment processes, and to increase the inhabitants' comfort. These are the main objectives, and now the question is how to serve those objectives and find the right use cases. As mentioned before, the use case terminology we've created in Bim-Speed is divided into those renovation goals, which are the aims to be achieved, the overall goals, for example, or give an example here is reducing the energy consumption. And then we have the business processes. Business processes are not directly related to BIM. It it's more a process which has been done since several years with or without BIM. So what we are doing in a common way for each project to serve specific renovation goals. For this example of energy consumption reduction, it is, for example, an energy analysis. You have to do it to achieve the goal that you would like to reduce the energy assumptions. And in the third step, you may talk about BIM use cases. So a BIM use case is a use case which is supporting the business process you're doing anyways. So the usage of BIM to support the energy analysis would be a BIM-based energy analysis. And then you have several methods how to perform the BIM use case. And that's, for example, the transfer from a BIM model to a BEM model, so a building energy model to serve or to be used as a base for the BIM-based energy analysis. So if you think about such a tree structure, we were able to create a large table where all those information come together. And to make it a little bit more readable, we have on the left-hand side the goals we would like to achieve with small pictograms. And then you see several explaining columns, and the blue ones are those which I brought to your attention on the slide before, and how they are in connection. And by setting up such a huge table, and after that we added more information when it popped up, we were able to define a requirements approach. So if we define the overall goals we would like to achieve, we may break it down to the business processes which will serve those overall goals and identify use cases. And finally, it's possible to break it down to the data to be collected. And talked enough about the backgrounds of the tool. In brief, I would like to show you this tool. One additional information, this tool is based on a simple Excel sheet, so it should be usable by everybody. Only special functionality we used is the Power Pivot functionality, which is included in Excel as well. And yeah, the tool is pretty self-explaining because we have all the information directly integrated into the tool. First step is to choose a specific goal to be used, or several more. And for this example, I'm going for time reduction. So you see some filters popping up, and we see that a filter has been set. And in the second step, we would like to go for the execution of renovation works, for example. And you see it will be filtered down. So it will be broken down that only the relevant use cases will be shown. Here, I would like to go for the issue management on site. And we see two methods. One is directly getting for localization, assignment, and tracking. And the second one is going or the usage of mobile forms to integrate the information. And I will go for the mobile forms. In the light purple fields, there should be more explaining about the use cases and the methods. So it has to be enhanced when the Bim-Speed project is going on. And finally, you will see in the lower fields which information to be collected. For sure, if we use mobile forms, it's not required to have any measured data to be collected, because we are using the mobile forms to collect those information. And it's possible to, or it's usable if you have a timestamp and the current weather data, for example, on the sensor side. And regarding the 3D model data to be collection to be signed, it is very useful to have a project, a PBS, which is a project breakdown structure, which is a definition where you are located, or with other words, how information is linked to each other, the location identification code where you're placed, and possibly the plant identification code if you're referring to MEP objects. So that's what has to be collected. For sure, it's not the best example, but as I said, we changed the lower part, the data to be collected totally. In the first version, it was more specific to specific items which has to be collected. But right at the moment, we are about to connect this with a maturity matrix as well as with a BIM passport, which is the identification, how useful the data you have already at hand for a project is to serve specific use cases. And therefore, yeah, this methodology toolkit is a work in progress, and we are adjusting it slightly, but you can have a first glance on the Train the Trainer website where you will find it and test around to collect the information for your projects. And that brings me to my last slide. Yeah, many thanks for watching and for your time. And yeah, as I stated out here, knowledge is about required information empowers smoother refurbishment. So with other words, you have to be aware which information you have to collect to avoid collecting as much information as possible and having a bunch of information which is not used anymore further on later on. So many thanks, and yeah. In case there are questions, I'm looking forward to the next Q&A session after Bogdan's next presentation. Many thanks.
Thank you very much, Yannick. Yeah, now we are running on time. That's great. So, Bogdan, could you please share your presentation?
Yes, thank you, Larissa. Thank you, Yannick. I will share my screen and my webcam. Let me know when you can see it. Wait a second. Okay, can you see my screen?
Yes.
Okay, thank you. Good morning or good afternoon, depending on where you are located. My name is Bogdan Tofan. I'm with Arcadis, and we are the lead author of this guideline called Method for Surveying and Diagnostics of HVAC Systems in the Existing Buildings. A short description of the guideline. So the scope of this guideline was to establish a source of knowledge where we present the technologies, methods, techniques that we can collect information from HVAC installations from an existing residential building, as well as researching how modern techniques could help identify objects, equipments inside the existing building that are part of this HVAC system. And another useful tools that we developed in this deliverable were two scripts that can be used by BIM modelers to assist them when after they have modeled some objects in their 3D BIM model, just to make sure that they have all the elements modeled accordingly. Like I said, the purpose of this methodology is to understand what data can be collected from a HVAC system, where to use it, how to use it, and when to collect it, because it's not always necessary to collect all the data if you are performing only some BIM use cases. And this is why for each technology or method, we exemplified it by recommended where to use it in BIM-Speed use cases. As also Yannick mentioned in the previous presentation, the methods are linked with the BIM use cases. The tools that we developed in this deliverable, like I said, the authors of this guideline made an algorithm of image recognition, so that it's easier for the stakeholders of the project to identify the equipments. This was a feasibility study, so we just tested to see if this is possible to use this sort of algorithm. And we tested it on two equipments, radiators and gas-fired boilers, with good results, but I'll show you later a few more detail. And of course, we showed where these are possible as well. Who can use the tool? The tool and the guideline, basically. So the methodology is addressed to engineers that go on site and gather the information, because they will know what and how they can collect the specific data and where to use it. And also for the BIM models, because as I mentioned, each technique that is used to collect data has an output that can be used or not to create a BIM model. So in this sense, we made the connection between the engineer and the BIM model so that they both have an understanding of the output of what they will collect and in which form it will to be collected. Main topics. So I will describe shortly the technologies and types of data and how the material is structured. I will share some information about the image recognition tool that we tested, and with the screenshots from the software, and I will detail a little bit more about the two scripts that we developed in this deliverable. So the data. Here are the technologies and methods that we presented in this guideline. So 3D scanning, photogrammetry, wall scanners, robots and drones, thermal imaging, existing drawings and manual inspections. All these methods have a more or less similar approach. We presented for each type of data, equipment and technology that can be used to acquire them, how to collect the data using those equipment or technology, how to process the data accordingly so that you will have the BIM model set up accordingly and optimized in time, so you won't waste time creating a BIM model based on the data that you collected, and examples of the BIM use cases where that data can be useful or needs to be collected, because in some BIM use cases you need to collect some. It's mandatory to collect some parts of the data by using that technology. The recreation of the HVAC model. So the image recognition tool that was developed by Cartif, which has also later on some presentation in this workshop. So the image recognition tool is a feasibility status, TRL5. Like mentioned previously, we just tested to see if using this technique is possible to identify equipments inside residential buildings. We concentrated on gas-fired boilers and radiators to see if this is possible, because these are the most common equipments inside the residential building. The focus was on object detection and classification, and we wanted to see what are the difficulties, bottlenecks in going further with such a technique, in order for other project owners or other companies that want to develop such a tool, they will know about. For this tool, the Google TensorFlow platform was used. These are some screenshots from the software that our partners Cartif developed. Like you see, it's looking only for radiators and gas-fired boilers. The accuracy results obtained have been satisfactory. Having this in mind, the accuracy can be further increased, but it will require a large database of pictures to train the algorithm. This was the one of the big setbacks, that we didn't have a big database of pictures for HVAC elements. And other possibilities to improve the accuracy will be to have a database with correct label images, so that the algorithm will improve his uses. Moving forward to the last topic, completeness of HVAC BIM 3D model. Like we said, we developed 2 scripts using Autodesk Dynamo. So the scripts may be used only for Revit users, starting with 2019. The 2 scripts are as follows. The first script detects the correct placement of objects inside spaces. What this script actually does is that, since placing HVAC elements in a model sometimes is a very routine work, because you may do one apartment and then just copy it to the other floors, but also because there are a lot of items to model in a HVAC system, heating, cooling, and so on. Sometimes the object may be placed in an incorrect space. For example, you will place a radiator in, I don't know, for some reasons, in a storage space or something like that, where it's not required and even it's not existing. So we developed this script to check that all the radiators are placed in the correct space. The gas fire boiler is not placed in an incorrect space, in a bedroom or something. And what also this tool does is performs also a check to see if the thermal output of the current radiator is enough with the heat load required by the room. But of course, only if this information is filled in the model. So if it's filled in the model, the script can also have that check performed. Another tool that we developed is to detect pipe valves or other fittings. Like I said, depending on the type of the building, the size of it, we can have a lot of elements, pipes, valves, fittings, and so on. And sometimes they can be missed, or sometimes you don't have the information that they are placed, and the BIM modeler does not place them there. So this script, what it does is, on a branch that you select, it identifies if you have the valves or not, so if they are missing, and if they are placed correctly. So you won't place a valve, for example, if it's I know, a radiator valve, you won't place it at 1 meter near the radiator. It should be close to the radiator, and so on. So it performs this kind of check. It can perform on the whole system entirely, for each type of valve that you select, or only on branches if you want, depending on the size of the model. More detailed, you can find it in the guideline there. It shows what packages you need to install and what versions should be used. Like I said, it was made for Revit 2019 and can be used for other versions, but some difficulties may appear on different versions, because also Autodesk changes a lot. And we'll try to issue for each version of Revit a different tool to be sure that they are working on it. This was the presentation. Thank you very much for listening, and if you have questions, please feel free to ask. I will stop sharing now.
Thank you, Bogdan. Yeah, this is now time for questions. If you have any questions, please raise your hand or just ask.
So in case there are no questions, it's possible to send the questions later on, so no problem.
No.
I could have asked a question though.
Sure.
Yeah, thank you. you seem to be collecting data from so many heterogeneous sources. What were the challenges in bringing this data together, please? You can share with us.
I guess this question is going to Bogdan.
Yeah, sorry, yeah, the last presenter.
Okay, so yeah, like I said, we identified techniques on how to collect data from using different sources, and using the BIM guideline that we developed in another deliverable. There we say how you can use those to create the BIM model. So not every information can be used to create the BIM model, but it helps in making the BIM model more accurate. For example, if you have a radio frequency scanner to detect pipes in the wall, you will not be able for that output to create a BIM model based on that output, but you'll know that, okay, you need to model that pipe in that structure, in that architectural element. So this kind of thing, the guidelines, this kind of information the guideline shows. For example, if you have a point cloud, then it's easier to create a BIM model out of it, but for some data, it's not possible directly. I hope I answered your question.
Yeah, that's fine, thanks.
Any other questions?
Then on with the show.
If there is no other questions, then we move to the 3-2. Javier, could you please share your presentation, please?
Hi everyone, this is Javier. I'm a researcher here in Cardiff, and today I'm going to show you the 3-tool plugin for Revit. So let me share my screen with you. As you may know, the 3-tool is a plugin for Revit, and it is intended to automatically detect and generate walls in Revit using a point cloud as a raw material. And the Revit version that I'm using today is 2021. So once installed, which is as easy as copying the plugin files in the corresponding folder, a new icon with the name Bimsp will appear in the ribbon in the section of plugins. So when we click on the icon, the first thing we can see is the loading page. In this form, we click on select, and we can select the point cloud that we want to work with. We can work with a variety of formats such as PLY, PTS, PTX, and so on. So today I'm going to be working with this point cloud. And now we are loading the point cloud in the program. This may take a while since it is 50 million points, so it's rather large. Now we can see that the point cloud has been loaded, and we can interact with it. And once we have finished, we close this window, and in this form we can see some parameters of the loaded point cloud, such as the number of points and the format. So the next step is the processing step, and here we have two main controls: the div size, which allows us to decrease the number of points that the tool uses internally, and lower values increase the number of points of the preprocessed cloud. I'm going to set this to 0.03, and the second parameter is the standard deviation of the filtering process, which decrements the number of noise of the cloud. Finally, we can click on the offset checks to align the cloud to the corresponding coordinated axis. And there is one more control, the configuration loader. We can see the current configuration, for example, and we can load as well a predefined profile that we have saved. So I'm going to press the process. This may take a while. We can see the output of the tool. And we can see that we have initially 50 million points, and now we have 500,000 points only. So the next step is the segmentation process. And I may say that we can always go back to the previous form with this button. And this step generates several small point clouds from the next one, because it's rather long. We can modify the minimum number that a cluster should have to be considered as a valid segment. And we can set how aggressive the segmentation is with the smooth threshold field. Finally, we can filter the generated segments. So with the predefined values, I'm going to segment this cloud. And this is again is going to take a while. So please bear with me. So as we can see, there is room to improvement. So we can modify the values to improve the final result. So I'm going to load another set of parameters, and I'm going to segment the cloud again to improve the number of segments that the take. So we can see that we have a better result now. Now we can click in next, and we go to the analysis for, and we can select the parameters of the analysis step here. Even though we have segmented the cloud, we still need to detect the planes that are present in the cloud to generate the walls of the building. The percentage of inlays and the distance threshold are options to select only certain points of the cluster that are candidate as planes, here and here. The edge and vertex options are for the refinement of the analyzed walls. The edge detection is the maximum threshold distance between the common edges of neighboring planes, while vertex replacement is the maximum threshold distance between theoretical and virtual vertices. Once we have selected the parameters, we click on Analyze, and we are going to see that all the detected walls are shown in red in the view. So we have detected more than 100 planes. Finally, we can try to refine the analyzed features. The intersection checks enables the auto-detecting of neighboring planes. The normalization check enables the normalization of edges and offsets of the walls. And the ignore check automatically discards walls which are area lower than the selected threshold. We click in Parameterize. And once this has finished, we can see in this dropdown the values, the planes detected, and the values of the coordinates of the points. For example, this, we can see the parameters. Finally, we have to select the wall type that we want to, for the walls that we are going to generate in Revit. This is just a warning. This means this, and we have generated 88 walls. So as you may, and this is the final model of the walls detected with the Stage tool. So this is all from my side. So thank you, everyone.
Okay, thank you, Javier. We are running super on time. That's super great. So let's move on to Roberto. We've been to Back to Bim, please.
You're on mute, Roberto.
Hi, Roberto. We cannot hear you.
Do you hear me now?
Yes.
Okay, and do you hear me well?
Yes.
Okay, so this is sorry, pongo el mío. You hear me now? Because we are having some troubles with the microphone.
Yes, yes, we hear you.
Okay. So I think it's now.
Now without echo.
No? No. Sorry, give me 1 minute, please, because we are experimenting some issues with the microphone because we are Javier and me together in the same place, and yeah. So
now we hear you perfect, Roberto.
Roberto, you are muted.
Yeah. No. Hello, do you hear me?
Yes, Roberto, yes.
Sorry for that. Yeah, again, I'm not sorry because we are together in the same room and yeah, switching between different microphone and yeah, was quite tricky. Sorry. You see the presentation of in your screen? Maybe back to the Cartif. So this is Roberto Sanz again from Cartif, and I will show you how to use and for what we have developed this backend to Bim tool. And yeah, okay, let's go. So the first slide, it says short description. Okay, this tool is the intention of this tool is to have the possibility to generate new monitoring projects for demo site building, to store dynamic data, and then to have the possibility to download this data of these demo sites for only one site. I mean, this is there are many different IoT tools and developments, and this integration tool try to put everything together from the Bim-Speed platform. The user only has to go to connect, to the Bim-Speed platform, and then everything is there. Okay, they don't have to go to other different IoT platforms or storage systems. So the use case is quite simple. It's a storage of dynamic data from buildings. We also update the IFC file of the building with information about the monitoring system. Then we have dynamic and real data from buildings, which allows us to have better simulation models and yeah, to be used in other tools, for instance, building energy performance simulation tools or whatever similar. So who can use this tool? This tool can be used by any professional who wants to get dynamic data from buildings in case there are monitoring systems installed by Forestry. And these data are stored in a platform following the ILC standard. this is part of the interoperability requirements that we have in Bim-Speed project. So the first, let's say, bullet that we have to consider is that the installed equipment must be compliant with the specification of the tool. In this specific case, this project, we will be using the Comfort platform, which is a development from the UniVPN, and the Energo Monitor, which is an IoT platform installed right now in the demo of Vitoria in Spain. But this tool is very adaptable and configurable, and we could include other monitoring system or protocols definitions. So we are using this tool to get dynamic data again, which allows us to have the possibility to make a very accurate building simulation models, for instance. As main topics, we have just 3. The first one is the installation of equipment on demos. Then we need to generate a configuration CSV file. We will see it in a demo, in a live demo that we will see in 1 minute or 2. And then we need to have also the IFC of the building. The use of the tool we will see in this demo, and the results, there are mainly 2. We will have the possibility to download data of the buildings, and then we also have the IFC of the building updated with some information of the monitoring system. Installation is quite easy. The first step is the proper installation of the hardware in buildings. Then, once the installation has been done, we have to create a CSV file for the configuration of the platform. You will see an example of this file in the bottom table of the screen. In this case, it's done for the Energo Monitor platform. There are some parameters that we need to set up this monitoring system into our platform. So to see the use, we will see a live demo just in 1 minute, but maybe our results that we are having in the left part of the screen, we see that we have 2 different formats for downloading data, which is JSON and CSV. JSON is very, very standard format today for the ICT systems. So it's a good idea and a very standardized form to get data and to put everything together, and it's very useful for the interoperability. And then the CSV is quite used, and it's very known by all of us, and it's very simple. We have different columns separated by semicolons, and yeah, you know. And then, as you can see in the right part of the screen, we will see the original IFC of the building, which is, let's say that the spaces here, they don't have anything about the monitoring system. And then when we run the application, we have some information about the sensor installed in the building. Yeah. So now I will do a very quick live demo. I don't know if you still see my screen. Do you see the Explorer? Sorry, I have to change. Give me please 1 minute. You see my screen now? Yeah. So this is the Bim-Speed platform in which we have created, for instance, in Aldave 26, which is a demo from Vitoria, we have created this folder back into Bim, and we have included these both files. I have to say that this house IFC is not the proper demo of Vitoria. It's just a file to test the tool and to show the achievements, but there we can see it. It's just very sorry. Very simple house, let's say unifamiliar house. Very easy, and if we explore this spatial structure, we see that in the main floor. You don't see it? Sorry. I don't know if I can move to this. Yeah. Okay. You see now. This is the model, the IFC file. These are the spaces. So there are nothing related with the monitoring system. They are all of them empty. So I move again to Explorer. Sorry, I don't know why I have to do this way, but anyway. So and here, this is the CSV file, as you have seen in the previous slide. I'm not opening because I guess that I have to move again and change the display that I'm sharing. Anyway, to execute the tool, we click on these three dots, access to services, and then here there are many different tools that the partners of the BIM-Speed project we have developed. So our tool is the button to BIM. So clicking on go to the service, it opens a new interface. This, oh, I have to move again. Sorry. This one. So this is the new interface, and this is our tool. So we have here new monitoring project and download data. The first tab, new monitoring project, we just have to fulfill this square box, and then house IFC file and house CSV file come directly from the Bimsp platform. So clicking on new monitoring project, it takes more or less 10 seconds, something like that. I'm changing again to the other Explorer window because we will see the results here. So the tool has automatically generated this house backend IFC file, so we can open it to see the differences among both files. So I will change again my screen. Where is it? Sorry, give me 1 second, please. So this is the new file that we have generated. You can see the name, house backend IFC file, and then if we explore the spatial structure, we will see that here in this space we have kind of sensor. Okay, we can go to it, exploring the spaces. This sensor is this square form. And then if we go to the other, we have here in other space the other sensor, which is here connected. Okay, so the properties of this sensor we have here: global ID, this name, the object placement and the representation. For sure, you can see that it's a square form because the tool doesn't have the possibility to know the geometrical structure of the sensor. We have done some tests with a family of sensors from Schneider, which are called Senta, and we have the IFC model of the sensor, and then we represent this kind of sensor properly. But when we don't know this, or when we don't have this IFC of the sensor, we cannot represent them in a proper way. So we make like a square box to tell the user that in this space there is a sensor installed. It's the only one information that we can give in this point. So if we go again to the tool, sorry, I move again to this. Sorry. Yeah, the tool generates automatically an account on ThingsWorld platform. This platform is an IoT platform that we use internally in Cartif to store data, to try to put everything together. As I told you before, there are many different IoT platforms in the market, and the target of this tool is to have all the data for the Bim-Speed project accessible from the Bim-Speed platform. So the users have to go to their email account, and then you will have probably this email activate your ThingsWorld account. So we only have to create a password for our account. It's very quick and easy. And later on, we will see why we are doing this. Okay. So the password is created. Now we can close this window because it's not useful, and the users don't have the need to go in to log in this platform, just to create the password, and everything is done. So close this window. I move again to the tool. Sorry. So we are here in our interface, and once we have created this monitoring project, you have seen we have this IFC file updated, and then a new driver for connecting to the EnergoMonitor platform, in this case, is running in our server in Cartif. So now, if the users wants to download data, they only have to go to download data, fulfill these squares with the email account that we have created and the password, and make login. And then this is the project that we have created before, and these are both sensors that we have in the project. Note that this naming is the same as the IFC naming, but the UID of the device. And then we can select in the both format to download data, JSON or CSV, and the dates. So it has been today is sorry. From 27th of April to, for instance, to tomorrow, and then download. We have this here, this JSON file. I'll try to open it to show you. I guess that you don't see this, so I have to move again to this. This is the JSON file that we have. This is the timestamp in the Unix format. Value, they are showing just 0 for this variable W, which is power, and for the variable WH, we have also measurements. We have also temperatures. We have also humidities, and yeah, you see here some values of the humidity. At this time it's 78, sorry, 78. Sorry for the Spanish. And yeah, you have to note that the monitoring project was set up just 5 minutes ago, and then this monitoring system is recording data every 5 minutes, so we only have one data. But if we download data, for instance, tomorrow, we will have, I don't know, 100 lines on this file, something like that. And yeah, if we go again to Croquis, sorry, to the Bim-Speed platform, we go to the Bim-Speed platform here. We see that automatically this JSON file is also stored in the platform, containing the start data and the end date for the data. And this is all from my part. If you have any question, it's time to do.
Thank you, Roberto. Yes, so if you have any questions, please. Okay.
I would have a question, but for the previous presenter.
Yes, please.
To the previous presenter, not Roberto.
Yes, Javier.
All right, Xavier. Thank you. Your presentation was great, Xavier. The last slide where you generated your model in Revit was quite interesting, because most tools would allow you but to have to retrace the point cloud data in Revit. But you seem to have generated it automatically using your add-on software for Revit. Is that the case?
Yes.
Okay.
It's,
now, when you maybe when you generated it like that, if you click on, say, one of the, so for example, walls there, and then you edit, can you see the real properties? Because you seem to have generated automatically.
you can see the
Your last slide will be interesting, please.
I'm going to show you the final result in Revit, and we can click in each of the generated walls, and we can modify the parameters of the wall.
Okay. So if you go to editor typo, where you have it there, right? Editor.
Excuse me, editor.
Edit typo, where you have it in, I don't know, it's in Spanish.
Editar tipo.
Yeah, typo, yeah.
Okay. I'm sorry, because I'm not a very Revit is not a program that I usually work with, so I'm a little bit.
It is in propriedades, below muro básico, editar tipo.
Yes.
Above.
Yeah.
If you right click.
Okay, sorry.
So this data that you have here, it comes automatically when you generate a model without you having to edit it.
Yes, this is automatically generated, and in the last point where I can select, for example, the type of wall, as you can see, this is set here. So right. I can select the type of the wall that we are going to generate in Revit.
Okay. That's really good.
Yes, excuse me.
No, I'm saying that that's good. That's good.
Okay.
If it does that, then that's excellent. Thank you.
You are welcome.
Thank you for your feedback.
But I tried to find this software online. I couldn't find it. How do I download it and try on Revit 2021?
As far as
maybe I can answer you, because we finished the integration of this plugin yesterday. No, I'm lying. We have finished this proper morning in the very beginning of the morning. So I can again share my screen, and then sorry. sorry. It's quite similar to the, let's see if now we can go properly. Once we have in the Bim-Speed platform, in this, at least in this folder structure, my colleague Sonia has created a new folder also, which is Point Cloud. And then from here, with this format, for instance, you click on access to service in the same way, and then you go to 3-tool here, go to the service, and then, yeah, you have to click on this agreement, because if not, it's not possible to download the installer, and then download the file, which is, if I'm not wrong, is a demo version right now. Javier?
Okay.
So you have now the file available to install on Revit, and you have nothing to do here in this screen.
Thank you.
So
Okay.
it's quite easy. It's the same way. Yeah.
Yeah, it's a great tool. Thank you very much. I'll explore it.
Welcome.
Thank you. Is there any other questions? Okay. I think, yeah, I think, well, we are getting close to 11:30. We have a few minutes, but if we do not have any questions, yeah, we move on to the closing remarks. Okay, David, would you like to say the last few words?
Yes, of course. Thank you. Okay, just a few words to say thank you to everybody for attending this workshop, and we invite you to the last workshop that will take place the next Thursday. I think that with the same time schedule as today, or very similar. I think 10 o'clock. We will send you the reminder of the invitation that we sent last week. Well, you will have in your email in the next hours or days a survey about what we have been presenting today, and we will be thankful if you could give us your feedback about the training material, or whatever you think that it's important for us to know. And well, I think this is all. We are very punctual and very on time this time. So thank you very much to the presenters. Thank you very much to all the attendees, and see you on Thursday, hopefully. Bye-bye.
See you on Thursday. Bye-bye.
Bye-bye.
Bye. Thank you.
Bye. Thank you.
Bye.
Thank you.